accuracy and precision. Okay. Now, when we are going for any kind of measurement, that means what? Why do we measure? Because when we are going on with any kind of experiment. So that means when we are going for any kind of experiment and there is a need for measurement, there is a two important things that comes to our mind, that is accuracy and precision. Accuracy means what? How much accurate, or that means how much close you are to the correct value. That is what is accuracy. So it refers to the closeness of a measurement to the true value of the physical quantity. For example, if a length of a particular material, that is a true length, if I say true length is 5 meter. Now, if you say, if your measured value is coming out to be 4.9 meter, that means what? You are very much close to the true value. That means what? This has good amount of accuracy in it. But if your measured value is coming out to be 4.5, that means what? You are quite away from the true value. That means this is less accurate. So this is more accurate. This is more accurate. And this is less accurate. Okay. Now, do not confuse with accuracy with precision. What is the meaning of accuracy and precision? For example, precision refers to the resolution or the limit to which the quantity is measured. That means how much precise value. That means after decimal point, how many digits or how many places that you are actually defining for your measurement. For example, if the true length is 5 meter, measured value I have given is 4.9 and 4.5 as an example. Here consider true value if it is 5 meter and someone's measured value is 4.9 meter. And if another child gives me 4.672 meter. That means you tell me which one is accurate. This one 4.9 meter is accurate because it is close to 5 meter. But which one is precise? 4.672. Got it? So that means it depends on the least count. Least count means the maximum, or we can say minimum value that we can measure with a given instrument. Minimum value. So what is the minimum value with this instrument that you have used? 0.1 meter, and this is 0.001 meter. Got it? So that means you can go up to 0.001. This is the least count. If you have any confusion about the least count, if you are having any confusion about least count, let me give an example. I think you all have a scale, the still small scale. What is the minimum value that you can measure? 1 mm, right? 1 mm is the minimum value that you can measure. 1 mm means how many centimeters? Can you tell me? How many centimeters? 0.1 centimeter. So least count of a scale that we use is how much? 1 mm. That means 0.1 centimeter. So that means when you are making any measurement, to how much precision can you give the value? You can give as 2.1, 2.3, 2.5, 2.8 or 7.8. That means after point 1 plus. That is why? Because your least count is 0.1 centimeter. Is that correct? So precision depends on least count and accuracy depends on how much close you are. So this one is more precise. So this one is more precise but less accurate. But this one is more accurate but less precise. Okay. Is the difference clear to all? If you have any kind of doubt, please let me know. So when we are doing any kind of measurement, that means what? There can be some kind of error, right? So when we are carrying on with our experiments, that means there can be some kind of error in the experiment. Now what is error? Error is basically true value, there is a difference of with the measured value. Suppose you are measuring one value and with your measured value, the true value there is making a difference. See, I haven't written here minus, this is not a minus sign, this is a difference sign. So if your true value, suppose you are making a measurement, your true value is found to be A, okay, and we can say your measured value will be A1. Now difference between these two values will give you what? Error. So when you are taking the measurement for the first time, that is the first reading that you are making, what is your measured value? This is your measured value. This is your measured value. And this is your true value. True value. Now difference between the true value and measured value will give you what? Will give you the error. Now there is a process of eliminating error. Process, that is a general process that we use. Process for eliminating error. What we do, let us understand. So that means what is your true value? That means your true value can be what? Just understand, your measured value, your true value will be what? Your measured value plus minus delta A. Yes or no? If this comes over here, what we can say? Plus minus delta A. Let me give an example. Suppose your true value is 5 meter length. Again the 5 meter. And your measured value is 5.1 meter. That means what should be the error here? Error will be what? 0.1 meter. Yes or no? Error will be 0.1 meter. So that's why your measured value minus this error will give you true value. It can be also possible if you are having 4.9, it can be also possible, suppose another person is taking the measurement, for that person it is 4.9. Then for that person, what will be the error? 0.1 meter. Yes or no? That is the true value coming out to be the true value. So what we do in general, we take these measured values. What we do? We take these measured values. After taking those measured values, we take a mean out of it. Mean value means average. So on an average, when you are calculating, suppose you are taking one reading, this is another reading, this is another reading. In this way, you are taking 5 readings or 6 readings. After taking out the readings, if you take a mean out of it, then what we can see, the measured value moves closer to the true value. Okay, so this is the general process of eliminating error. What is the general process of eliminating error? Taking mean of measured values near about provides us the true value. Let me just see an example. 5.1, this is what? Measured value. 4.9, this is what? Measured value. Are these true values? Not at all. If you add them, what I'm going to get? How many readings I have taken? 2. 5.1 plus 4.9, you are going to get how much? You are going to get 10. Divide by 2, you are taking the mean, so you are going to get near about the true value. Got it? Now this is how we eliminate errors. Now there are different types of error that we have to find out. What are the different types of error? Suppose you have done one experiment, and in that experiment I want to know how much error is there. Okay. So for that, what we do, there is a two process of understanding. One is relative error. Relative error. What is the meaning of relative error? That means you have done one experiment, and in that experiment the error comes out to be delta A. That means in your reading, that measurement that you have taken, your error comes out to be delta A. And what is the true value? True value, as I told, that is the mean. I am taking the mean of all the readings that I have taken. So this fraction of error to the true value of a measurement gives us relative error. Now, if anyone wants to know what is a percentage error, so percentage error is nothing. Percentage means if you want to find out in 100, that is nothing. That is fractional error. That is fractional error into fractional error into 100. That means percentage error we write like this. That is delta A by A into 100. That is what's your percentage error. Okay. So we have to understand. So we have understand what is error, what is the process of eliminating error, and you have to keep this in mind of relative error and percentage error. Next, we are going to understand how to calculate error, and from the given questions, how to solve all the questions related to error. Okay. So now we have understood what is error, why errors are occurred, because there are a lot of reasons for errors to occur. We can have problem in list count, problem in apparatus. We can have problem in apparatus, we can have problem in list count, and also we can have problem in ourselves also, right? So there are so many types of error can be possible. Now generally we consider error in the instruments. Okay, why? Because you are coming for an experiment and your concept is not clear and you don't know how to do the experiment. That kind of error is not considered, right? So now if any situation or if any quantity is there when you have to find a sum, for example Z will be is equal to sum of A and B. So that means you have to take a measurement of A and you have to take a measurement of B. So when you are taking a measurement of A, that means what? Is it a true value of A? No, there will be an error. So when you are going to take a measurement of B, will be a true value of B? No, there will be an error. So that means the error that you have found in measurement of A and measurement of B, that error is going to reflect on this one as well, right? So what we are going to understand, so that means this is the ideal value. This is the ideal value. So in general, practically you have to understand Z will be having some amount of error, right? That error will be what? Due to error in A as well as error in B, right? Error in A as well as B. So what is the error in your final measured quantity? So delta Z will be sum of delta A plus minus delta B. That means it is very easy to understand. Just see. So this is your quantity. This quantity can be found out from the sum of A and from the sum of B. Now A will be having some amount of error, B will be having some amount of error. So what will be the error that will reflect on this Z? That is Z equals to Z plus minus delta Z. So plus minus delta Z error will be this one. No negative, this will be added. Why? Because we always try to find out the maximum error. So if we try to find out the maximum error, then what will happen? We can eliminate the maximum error. Now tell me, in situation when there is a difference of two quantities, that means suppose Z is a quantity that can be found out by A minus B. That means what? You have to measure the value of A, you have to measure the value of B. Then you have to make a difference. Now understand, that means when you are doing this, while measuring A, there is an error in A. While measuring B, there will be an error, and that error will be reflected in Z. Yes or no? So delta Z, that will be the error in A, that will also be delta A plus delta B. Why I am adding here again the same part? Because I want to find out the maximum possible error. You can tell me, sir, this is A minus B. In this situation, when we are adding, we have got an addition, no problem. But here in this situation, we are subtracting. But still, why we are putting here plus? Because we want to find out the maximum possible error so that we can eliminate it. Okay. This is the rule to find out error. Now using these two, I have given some questions over here we are going to solve. Okay. So here what is said, A is equal to 12.0 plus minus 0.1. 12.0 plus minus 0.1. That means you can understand 12.0 plus minus 0.1. What does that mean? So 0.1 is the error in A and 0.5 is the error in B. So that means if I am going out with the solution, so A plus B will be what? A plus B will be what? 12.0 plus 8.5. What will it be? 12.0 plus 8.5. So here it will be 20.5. This will be 20.5, right? This will be 20.5. And what will be the error in this one? What will be the error? Error will be, what did I say? For any kind of summation, what we have to do? We have to add the errors. So error will be 0.1 plus 0.5, that is 0.6. Is it clear? Now here also A minus B. What will be the error? 20 minus 8.5. What will we are going to get? 20 minus 8.5. We are going to get how much? 11.5, right? 20. Very sorry. This is 12.0 minus 8.5. 12.0 minus 8.5. Now 12.0 minus 8.5, how much we are going to get? Any idea? We are going to get 3.5 plus minus how much? Error we have to always add in this situation, that is 0.6. Is it clear? Now let us do this one. Let us do this one. So what is say? Two resistance R1 and R2 is given. These are the errors in R1 measurement and R2 measurement are connected in series. What is the equivalent resistance? So series equivalent, I hope you all know. So what is the series equivalent formula? R equivalent will be R1 plus R2. So here what we need to do? We need to add. So 100 plus 200 will be what? R equivalent. 100 plus 200, that is 300. But what will be the error? What will be the error? This is 4 ohm and 3 ohm. So we have to find out always the maximum possible error, right? So here also this, see, this is the formula and this is the question. What? Here is a summation going on, there also summation going on. So here the maximum possible error will be 4 and 3, that is 7 ohm. So this is the error. So R equivalent is equal to how much we are getting? 300 plus minus 7 ohm. Got it? Now this one, temperature of two bodies T1 and T2. Calculate the temperature difference. So temperature difference will be what? Temperature difference will be what? Delta T, that is temperature difference. This is difference in temperature. Okay. So this will be what? T2 minus T1. T2 minus T1, right? So this will be, what is T2 minus T1? 50 minus 20 degree, that is how much? 30 degree. But in writing, in case of writing the error, we have to always add the error, that is 0.5 plus 0.5. That is how much? That is plus minus 1 degree. Is this clear? So this is the errors formula. These are the errors formula in situation where you need to find out the summation or subtraction, and this is how we are going to solve the question. Is it clear? So here we have some other kinds of error calculation. What is it? See, if there is any quantity that needs to be multiplied to get another quantity. Suppose A multiplied with B to get Z. So in that case, if you need to find out the relative error of Z, what is the way? Delta A by A plus delta B by B. What is delta A? You understand now? What is delta A? Error in measurement of A. What is delta B? Error in measurement of B. Similarly, in case of division as well, Z is equals to A by B. So if you have to calculate the relative error of Z, that is delta Z by Z, then what you have to do? Delta A by A plus delta B by B. Same thing. Now, this is the general case. This is the most important one, and you need to use this one more often compared to these two. Let us understand here. Z is given as a to the power b, b to the power q, and c to the power r. Right? Now, a to the power p, b to the power q, and c to the power r. See, if you have to find out delta z by z, this part is very easy. Delta a by a, delta b by b, delta c by c. But what is the power of a? P, so you multiply with p. What is the power of b? That is q, you multiply q. What is the power of c? R, that is r, you multiply with this one. Okay. Now this formula will be absolutely very clear to you the moment we are going to solve these numericals. Okay. So please everyone keep this in mind, and we are going to solve these numericals. Let us understand. Z equals to a to the power 4, b to the power 1 by 3, c d to the power 3 by 2. So what will be the delta z? So they are asking what will be the relative error. So delta z by z will be what? Delta a by a plus delta b by b plus delta c by c plus delta d by d. Now you tell me, what is the power of a? 4. So 4 needs to be multiplied here. What is the power of b? 1 by 3. So 1 by 3 needs to be multiplied here. What is the power of c? Nothing, that is 1. So no problem. What is the power of d? That is 3 by 2. So 3 by 2 needs to be multiplied here. Is it clear? That's how you get the percentage error of, that's how you get the relative error of z. Is that clear to all? Now, if I am going with the specific resistance, if I am going with this one, specific resistance, let us see what is the question asked. Here specific resistance is given. So the question will be here, find percentage error of this specific resistance. Now, how does it depends on specific resistance? That is delta sigma by sigma. That this is the first thing that you need to find out. Delta sigma by sigma. Pi is what? It's a value. Pi is what? It's a value. You don't need this. So R square, capital R, and this L, these are all the measured value, right? So your sigma depends on these measured values. So you are not going to consider pi because it's just a value, constant value. You have to consider what is the measured value. So it depends on what? R. So this will be delta R by R. What is the power of R? 2 plus delta capital R by R. Power of capital R is what? 1 plus delta L by L. Power of L is what? 1. Is that correct? Now delta R is of course this one. Delta capital R will be of course this one. Delta L will of course be this one. So now you put this over here. This will be how much? 2 into delta small r is 0.02 by 0.26 plus delta capital R is how much? 1 by 32. This is 1 by 32. Delta capital R is what? 1 and R is 32 plus delta L. L will be what? 0.01. What is capital L? 78. Right. Now the question has asked, find the percentage error of sigma. Percentage error means delta sigma by sigma into 100. That means this entire part that you have got here that needs to be multiplied with 100. This will give you the percentage error, right? Please calculate this one and let me know. And the third one, this third type, this is quite a common numerical, especially we get this kind of numerical in NEET. So what we have to do, physical quantity is already given, how does it depend? And percentage error is also given, that is 2%, 1%, 3% and 4% of all these quantities. Calculate x. Very easy. Let us find out. So delta x by x, that will be what? Delta a by a into 2 plus 3 delta b by b plus delta c by c plus d to the power root means what? Half. D to the power half. So half will get multiplied with delta d by d. Now the question is asking percentage. The percentage is given. That means you have to multiply. You have to multiply delta x by x into 100. Yes or no? In order to find out the percentage error, that means with all these quantities you have to multiply 100. So let us make it very easy. So 2, if I multiply 100 with this one, this will be what? Delta a by a into 100. Then what is the percentage error of a? 2%. I am writing here directly. Similarly, when we have multiplied 100, what we are going to get? 3 into delta b by b into 100. So what is percentage error of b? 1% plus delta c by c. What is the percentage error of c? 3%. So you have already multiplied with 100, so you are getting 3%. And this one, d is how much? Percentage error of d is 4%. So you get half delta d by d is 4. So when we are calculating this, we are getting 4 plus 3 plus 3 plus 2. So 4 plus 3 plus 3 plus 2. We are getting here 12. So 12% is your percentage error. Got it? So what is your work? You please take a screenshot of it or note it down in your copy. And most important part is that calculate this one and let me know what answer you are getting. Let me know what answer you are getting. This is the solution. This was the question. Again, this was the solution of this question. Okay. Is it clear? If any doubt, please feel free to tell me. Okay. This ends up your errors, calculation and your first chapter, dimensional analysis. I'll see you in the next class. Thank you.